Welcome to the domain of cyber attacks. In this domain, we're going to explore a range of attacks, starting from password attacks, brute force attacks, dictionary attacks. We're also going to have a look at denial of service and distributed denial of service attacks. We're going to see how DNS attacks can cause problems. And then we're also going to focus on attacks that are targeted towards networks. And finally, attacks which target people, such as social engineering and phishing. So let's start with password attacks. Let's start with brute force attacks. As the name suggests, brute force refers to trying all possible combinations to guess the password. Now, one thing is certain about brute force attacks, and it is that given enough time, it can break any password in the world. However, the problem is the time. So, for example, if your password takes 1000 years to break, then for all practical purposes, you can consider that password to be secure. Now, there are two criteria which determine how hard it is to break the password using brute force. So the first and perhaps the most important is the password length. The longer the password, the harder it is to break. So for example, if your password consists of just numbers and you're using, let's say, 3 digits, so then it's very easy to, just cycle through all the combinations right from 000 to 999. So always select longer passwords to make them harder to break. The second important criteria is the type of characters used. So for example, if you're using just numbers, then you have just 10 possible combinations at every digit of your password from 0 to 9, right? So for example, if you have, let's say, a password with n digits, and at every digit you can select alphabets from A to Z. So then you have 26 possible combinations for every digit, right? Because here you can have A, B, C, D, and so on up to Z. So 26 possible combinations, and then again 26 possible combinations. So now let's say if you have a password length of 1, then you have 26 possibilities. If you have a password length of 2, then you have 26 raised to the power 2, and so on and so forth. So as you can imagine, the longer the password you use, the harder it is to break. Now let's say you add numbers as well. You say that you can have A to Z, but you can also have numbers from 0 to 9, right? So then your possible combinations for every digit becomes 36. So which makes it stronger. So you should always use longer passwords, to increase this power of n. And you should also use more combinations. For example, you can add uppercase and lowercase alphabets. So then you'll have 26 plus 26, 52, and then 10, numbers. So you'll have 62 possible combinations. So it's always nice to select a password which includes uppercase alphabets, lowercase alphabets, numbers, and ideally, as we're going to discuss later, you should always add random characters as well, such as hash symbols, @ and so on, to make so many combinations that they're hard to break using brute force. Now, this is just a look at the number of combinations that you can have. Let's say if you have a 1-digit password and you have 26 possible combinations, then you have 26 possibilities. If you increase the number of digits to 2, then you have 676 and so on. But if you see here, when you jump from 5 to 6, you immediately expand exponentially. So you go 300 million combinations. For 7 digits, it becomes 8 billion. And for 8 digits, it's 208 billion. So you can imagine, just by increasing even one more digit in your password, you make it much harder to break. Now we're going to discuss some of the challenges of storing passwords. So always remember that passwords are never stored in plain text. For the simple reason that even if you consider your database to be 100% secure, you may still have a compromise of the database. And if you have all the passwords stored in plain text, then you have made the job easy for the hacker. Another problem is that sometimes users use the same password for multiple accounts. So, if somebody gets your password for one account, they may be able to access other accounts as well. So that's exactly the reason if you forget your password on a website or a web application, you can never actually get or see your real password because they're never really stored. You can reset your password, but nobody, not even the administrator, can see your actual password. Why? Because they're stored after processing. They're stored after hashing. We're going to see. So the passwords are always hashed and the hash is stored for security. It is impossible to recover password from hash since it's a one-way function. So hashing is a very interesting concept. The basic idea is that you give it an input and it creates a hash of that input, but there's no way to, reverse the process and get the input if you have the hash. So it's a one-way function. So whenever a user enters the password is hashed and it's stored. The next time when the user enters this password, the password is hashed again and compared with the hash stored in the database. So it's basically, authentication is actually a comparison of the hashes, not the actual passwords. Now let's see how this actually works. Let's say you type your password. Now this password would be passed through a one-way hash function, and this one-way hash function is going to create a hash which will be stored in the database. So for example, whatever password you entered, let's say you are user John, you entered a password. Now the password hash has been calculated, which would be something random like this, and this hash would be stored. So the next time when you enter your password, again a hash would be calculated, and that hash would be compared with this hash. If the two hashes match, then great. So you see, you didn't even need to store your password in plain text, and you still are able to authenticate. Now let's see two different variations of brute force attacks, online versus offline. As you can imagine, brute force attacks don't work very well online because they can only make a certain number of tries. After that, the account gets locked out. Because even when you enter your password incorrectly on web applications, you see after a certain number of tries, your account gets locked out. So that's a built-in safety mechanism to counter against brute force attacks. And also brute force attacks are very slow online because they need to, access the web page, enter the credentials, and then wait for the feedback. So it doesn't really work. However, it would be ideal for attackers if they can get their hands on an offline copy of the database. Now, once again, even if they have a copy of your database and that database has passwords stored, doesn't mean that the hacker has actual access to the plain text passwords, because as we discussed previously, almost always the passwords would be hashed and stored. So even if they get their hands on the database, doesn't mean that your system is 100% compromised. Now, the problem for the hacker is that he has the hash, but he doesn't know the password. So one possible way is that they try different combinations of passwords, they pass it through the hash function, and they try to check if the generated hash matches the hash stored in the database. Now this is a very slow process, makes it very hard. Now to speed things up, attackers often use something which we call rainbow tables. So what is this? In a rainbow table, what it does is that they have all the possible password combinations. Let's say you're talking about 5-digit passwords, right? So they have all the possible combinations for 5-digit passwords, and they have pre-computed all the hashes for that. So now their only job is to compare those hashes with the hashes stored in the database. So they don't have to actually compute hash again. So that saves up a lot of the time of the hacker. They don't need to compute hashes. The hashes are pre-computed and stored in the rainbow tables. Now this makes their attack more effective and more dangerous. Let's have a look at dictionary attacks, another interesting variation of password attacks. The problem with brute force attacks was that they were not really feasible because you have to try so many different combinations. So in the dictionary attack, you do something more intelligent. You try to play on human psychology and you try the words in a dictionary, because often people tend to use these words. Another interesting thing is that people often select common patterns of passwords. So a dictionary attack includes both trying words in a dictionary as well as these common words. Now based on research, these are the top 10 most common passwords. So as you can see, they are very simple, and there are a lot of people who still use these passwords. So there's a very high probability of discovering a password in a shorter amount of time. With the brute force, the problem is that you have such a big search space that you have to try billions of combinations sometimes. But in a dictionary eventually is still limited with the number of words, right? And the common password patterns are also limited. So the hacker has a good chance of stumbling upon a weak password using a dictionary attack compared to the brute force attack. Let's have a look at some of the best practices for protection against password attacks. So when we talk about brute force attacks, One thing which your web application should definitely have is account logout. So after X unsuccessful attempts, your account should automatically log out. You should never allow for brute force attacks to carry on without any sort of locking out. Another important concept is that after a certain number of incorrect tries, you should force the users to pass through CAPTCHA. So for instance, Google offers reCAPTCHA. It's a very interesting combination. The basic idea is to put a challenge on the screen which the user has to solve and only the humans can solve. Previously this used to be a bit more difficult. There used to be, characters which you had to type and, or maybe identify pictures. We still have that. But Google has, introduced a new version of CAPTCHA in which you just have to click once. And how do they check whether it's a human or a machine or a robot doing a brute force? Is the way you move your mouse within that screen. So they capture the movement of the mouse, and based on how humans move the mouse and the pattern, they can detect whether it's a human or it's a robot. Another interesting, or perhaps the most important thing, is to enforce good password policies. So you should make an IT policy and enforce it in our organization, which makes sure that your password should be relatively long. So 8 characters is the gold standard. This should be the least length of your passwords, because with 8 characters you have a huge number of possibilities, not really easy to break. Another important thing is that you should always include both uppercase and lowercase characters as well as special characters. Now this increases the search space, because at every digit you now have 26 plus 26 plus the special character, so a bigger space. You can always add numbers, of course. Another important thing to make sure is that you should always encrypt your databases. So the password is already hashed and stored in the database, but you still need to encrypt the database itself as well. Because even if your database gets compromised and you have used a state-of-the-art encryption scheme to encrypt it, it would be really hard for attackers to break that database. Let's discuss salting, a very interesting technique to counter brute force attacks. So if you recall, one of the most effective ways that hackers cracked passwords was that they get their hands on an offline copy of the database, and then they use these rainbow tables, because the database doesn't have actual plain text passwords, it just has the hashes of the passwords. So what the hackers do is that they have these rainbow tables which have pre-computed hashes of all the passwords. So now their job is very simple, to compare these pre-computed hashes with the hashes stored in the database. They don't have to compute the hash again and again. So one of the ways we solve this problem is through salts. A salt is a random number which we add to the password before hashing it and storing it in the database. This makes rainbow table attacks ineffective. Let's see how it works. So basically we have the password, then we add the random salt to it, and then we do a one-way hash function, which is, the final hash is stored in the database. Now since this hash is not just a hash of the password, it also includes the salt in it. So this makes it very difficult for the attacker to get the original plain text passwords. So for example, even if he correctly guesses the original plain text password, he won't be able to check whether it's the correct one or not, because he wouldn't have access to the random salt which was added when hash was created. So this adds significant security to the passwords. That concludes our lecture. I'll see you in the next one.